In this example, we have a block of mass m slides from rest on an incline with no friction. The block is positioned at the top of the incline with an elevation y. Find the final velocity at the bottom of the incline. The first step is to identify the variables that are given by the problem and examining the figure. First we set the origin at the lowest point the block will reach. We see that it starts at the top of the incline, and according to the problem it starts at rest and begins to slide down in a surface without friction, and so from there we see that it has no initial kinetic energy but only potential energy due to the presence of gravity and the position that the block is at, which is at an elevation of y. The final position is at the bottom of the incline, where there is a presence of velocity at the bottom but no height elevation. From there we can know that at this point it has a kinetic energy due to the presence of motion but zero potential energy due to gravity. The next step is to use the ideal equation for the problem at hand. So we recall the total mechanical formula and we rewrite this as the sum of the initial potential and kinetic energies equal to the final potential and kinetic energies. We then substitute the known and unknown values to the formula and we get the value for the magnitude of velocity, or simply speed, at the second position, which is equal to the square root of 2 times g times y.